11.3 goes over monomial factors of polynomials. The first part that we're going to be looking at is just dividing these binomials by a specific term. When you are dividing an expression by a monomial, you want to make sure that you divide each term within that expression by the monomial. So if we look at example 1, we're just dividing. For A, we have 5m plus 35 all over 5. So we're going to do the 5m divided by 5 as well as the 35 divided by 5. 5m divided by 5, the 5's cancel, so we just have m, and 35 divided by 5 gives us 7. So m plus 7 is that fraction simplified. For example B, we have 64x plus 88 all over 8. So again, we're going to do the 64x divided by 8 as well as the 88 divided by 8. 64x divided by 8 gives us 8x, and 88 divided by 8 gives us 11. So 8x plus 11. For example C, we have 48x minus 16y all over 4. So we're going to do the 48x divided by 4 as well as the negative 16y divided by 4. The 48x divided by 4 gives us 12x, and the 16y divided by 4 gives us a negative 4y. So we have 12x minus 4y. For example 2, again, we are just dividing. For example A, we have 26uv minus 39v all over 13v. So if you wanted to separate this, you could. It would just be 26uv over 13v minus 39v over 13v. To simplify, the 13 goes into 26 two times, so 13 becomes 1, 26 becomes 2. You have a v on the top and the bottom of that fraction, so they cancel each other out, and you're just left with 2u. For your next fraction, you have that 39v over 13v. 13 goes into 39 three times, and v over v cancels out, so it's just 2u minus 3. For example B, we have 8x plus 16xy all over 8x. So again, if we want to separate this, we would just have 8x over 8x plus 16xy over 8x. Your 8x over 8x, the 8's become 1's, the x's also become 1's, so it's just 1. The 16 divided by 8, the 8 becomes a 1, 16 turns into a 2. You have an x on the numerator and the denominator, so they cancel out, and you're just left with 2y. So 1 plus 2y is that fraction in simplest form. For example C, we have 24y plus 48xy all over 16y. So for this one, we're going to have the 24y over 16y as well as the 48xy over the 16y. When we divide these, you have 24 and 16. The 16 does not go into 24 evenly. However, 8 does go into both of those numbers evenly. So the 24 becomes a 3 and the 16 becomes a 2. You have y on the top and the bottom of your fraction, so cancel them out. So you're going to have 3 over 2 plus something. Now, because you divided the first numerator and denominator by 8, with the second fraction, you want to do the same exact number, so that way you have the same denominator and you can bring these two fractions back into 1. So if you divide the 16 by 8, it gives you 2. The 48 divided by 8 gives you 6. So this gives us 6 over 2. You have a y in the numerator and the denominator, so those cancel, but you do have that x still left in the numerator. So the reason why I'm not going to simplify this 6 over 2 to be 3 is because in order to write this in simplest form, you would have to have divided each of those terms by the same number. which means you have the same denominator within each of those fractions if you were to separate it. So if we bring this together, we just have 3 plus 6x all over 2. For example 3, we're still just dividing. In this case, though, we have a little bit more in our numerator than just those two terms. So example A, we have 3x to the 4th power minus 9x cubed y plus 6x squared y squared all over negative 3x squared. Because I have a negative in the denominator, and I do not want a negative in the denominator, what I would first do is to change the sign on every single term and rewrite this. So this 3 would become positive, the 3 up top would become negative, 9 would become positive, and the 6 becomes negative. This gives me negative 3x to the 4th power plus 9x cubed y minus 6x squared y squared all over a positive 3x squared. From here, the numbers that I'm working with are negative 3, 9, negative 6, and 3. Find your greatest common factor between the 3, 9, 6, and 3. It is 3, so divide each of those terms by 3. The 3 in the bottom becomes a 1. The negative 3 up top becomes a negative 1. The 9 becomes 3. The negative 6 becomes negative 2. So now we have a negative x to the 4th power plus 3x cubed y minus 2x squared y squared all over x squared. If you remember what we did in 11.2, if you are dividing your powers, you are subtracting their exponents if the base is the same. So anywhere you have an x in the numerator, you're going to divide it by the x squared in the denominator by subtracting 2 from its power. So this x squared cancels out. You're going to subtract 2 from the 4, 2 from the 3, and 2 from the 2 on all of those x's in the numerator. So this gives us a negative x squared plus 3xy minus 2y squared. For example B, we have 12x cubed y cubed minus 8x squared y plus 16xy squared minus 20y squared all over 4y squared. So looking at your numbers, you have a 4, a 12, a negative 8, a 16, and a negative 20. Ask yourself, does the 12, the 8, the 16, and the 20, are they all divisible by 4? In this case, yes, they are. So you can divide out a 4 from each of those numbers. This 4 would become a 1, 12 becomes 3, negative 8 becomes negative 2, 16 becomes 4, and negative 20 becomes negative 5. So ultimately, we're working with 3x cubed y cubed minus 2x squared y plus 4xy squared minus 5y squared all over y squared. Now, you still have a y squared in your denominator. So ask yourself, do you at least have a y squared in every single one of those terms in the numerator? If you don't, you cannot subtract 2 from all of the exponents on the y in the numerator. So if you look, you have a y cubed, you have a y. That y is not y squared or greater. So the only thing that you're able to factor out between all of these is a y. So we're going to subtract 1 from each of these. Remember, the y that doesn't have a power is to the first power. So this is going to give us 3x cubed y squared minus 2x squared plus 4xy minus 5y all over y. And again, we're leaving the y in the denominator because we do not have every single term that had a y squared or greater, so you cannot factor out a y squared from each of those terms. If we look at our next set of examples, for example 4, we have x cubed y minus 4x plus 6y all over xy. Again, if each term does not have that specific value on the top and the bottom of that fraction, you cannot cancel it out. However, with this, you can write it a different way. It's kind of going to look weird, and it's not going to be left as a fraction for all of it. So you're going to be separating it in order to do that. So this here, if you were told to keep it as one single fraction, you would leave it just the way it is. However, you can simplify it by separating it and then dividing out whatever you can. If you look at the first fraction, that x cubed y over xy, the y cancels out the x cancels out one of the x's on the top, and the y's cancel out, so we just have x squared. For the second, your x's will cancel out, so that's negative 4 over y. And then your y's cancel out, so that's 6 over x. For example B, we have a to the fourth power b squared minus a squared b to the fourth power all over a squared b squared. Again, if you wanted to separate this, you could. Do you have to? No, because each term up top has a power that's 2 or greater for both the a and the b. So we could just cancel out the a on the denominator by subtracting 2 from each of the powers for a, and cancel out the b in the denominator by subtracting 2 from the powers on b. This would leave us with a squared minus b squared. For our next example, we are factoring. When we factor, we are not told what our greatest common factor is between the terms that we're factoring. When that happens, you have to look at each of the terms within the expression and figure out on your own what is your greatest common factor. Once you do that, that is what you are dividing each term by. Whatever you divide from each of those terms will go out front of a set of parentheses. So if we look at example 5a, we have 5x squared plus 10x. Your greatest common factor between the 5 and the 10 is 5. The greatest common factor between x squared and x is x. So because you're factoring out the 5x, it goes in front, and what's left over will go in a set of parentheses. So 5x squared times 5x squared divided by 5x is just x, and 10x divided by 5 is 2. So 5x times x plus 2 is this expression factored. For example B, we have 8x cubed plus 16x squared. Your greatest common factor between the 8 and the 16 is 8, and the greatest common factor between x cubed and x squared is x squared. So because we are dividing out that 8x squared, it goes out front. What is left over stays inside the parentheses. So we're going to have the x left over from 8x cubed divided by 8x squared, and 2 left over from the 16x squared and divided by the 8x squared. So 8x squared times x plus 2. For example C, we have 24x squared minus 144x. Your greatest common factor between those two terms is 24x. We factor that 24x out, so it goes out front of a set of parentheses, and what's left over stays inside. You have x minus 6 left over, so 24x times x minus 6 is simplified. For example 6, we're doing the same exact thing. For a, we have 4x to the fifth power minus 6x cubed plus 14x. If we see with all of these, they are even numbers, so we can divide out of 2. Our lowest power on x is just 1, so we'll factor out 2x. Since we're factoring out the 2x, it goes out front. What's left over goes inside the parentheses. So 4x to the fifth power divided by 2x is 2x to the fourth power. The negative 6x cubed divided by 2x is negative 3x squared. And then the 14x divided by 2x is 7. So 2x times 2x to the 4th power minus 3x squared plus 7. For example B, we have 8y to the 4th power minus 3y cubed minus 2y squared. All of these terms are not divisible by a common coefficient, which means the 8, the 3, and the 2 are not divisible by anything other than 1. However, they all do have at least a y squared, so we can factor out the y squared from these. If we factor out the y squared, we're going to be left with 8y squared minus 3y minus 2. For example C, we have 9x squared minus 18x plus 27. Your greatest common factor between all three of these terms is just a 9. So we factor out that 9. We're going to have 9 times x squared minus 2x plus 3. For our last examples, for example 7a, we have 8a squared bc squared. Alright, so for a, we have 8a squared bc squared minus 12ab squared c squared. To factor this, our greatest common factor between these two terms, at least the 8 and the 12, is 4. For the a, your lowest power is just 1, so that's a. B, your lowest power is 1, so that's b. And c, your lowest power is the squared. So we're going to factor out 4abc squared. So that goes out front. What's left over goes in parentheses. So 8 divided by 4 is 2. A squared divided by a is a. B divided by b cancels out. C squared divided by c squared cancels out. From there, negative 12 divided by 4 is negative 3. A divided by a cancels out, B squared divided by b is b, and c squared divided by c squared, it cancels out. So we have 4abc squared times 2a minus 3b. For example B, we have 18xy squared z cubed plus 27x cubed y squared z. If you want to factor this one, your greatest common factor between the 18 and the 27 is 9. Between the x and the x cubed is x. Between y squared and y squared is y squared. And between z cubed and z, it's z. So we factor out 9xy squared z. We're going to have 2z squared plus 3x squared left over. So the only thing I did was I did the 18 divided by 9, I got the 2. The x and the x cancel, y squared and y squared cancel, z cubed divided by z is z squared. Then 27 divided by 9 is 3, x cubed divided by x is x squared, y squared divided by y squared cancels, z divided by z cancels.